Let's write a linear equation, y equals mx plus b, that's slope-intercept form, relating x and y based on this given table of values. To write a linear equation like this based on this table of values, we're going to need to find the slope, m, and the y-intercept, b. Let's start by finding the slope, m. You may have seen the slope of a line, m, written like this, delta y over delta x. That just means the slope is the change in y per change in x. And we can figure both of these things out easily looking at the table. Let's see, how much does y change at each step? It appears to be going up 2 at each step. 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11. So the changes in y are just plus 2. Now what about the changes in x? Those appear to just be plus 1. 1 plus 1 is 2, 2 plus 1 is 3, and 3 plus 1 is 4. From this, we know that our slope is the change in y, which is 2, divided by the change in x, which is 1. And 2 divided by 1 is just 2. So that's our slope, m. Then all that remains is for us to find the y-intercept, b. One way to do this is to take our equation and plug in information that we know. We know that m is 2, so we can plug that in. And then for x and y, we can pick any point that's given to us in the table and plug that into the equation. Let's say we plug in the point x equals 1, y equals 5. So we see that there. X is replaced with 1, and y is replaced with 5. Now we can just do some basic math to solve for b. Y is 5, m is 2, and x is 1. So 5 equals 2 times 1 plus b. We then just subtract 2 from both sides of the equation to get b by itself. 5 minus 2 is 3, and so we have that 3 equals b. And so that would be our final answer, 2x plus 3. We found the slope was 2, so we plugged that in, and we just found that the y-intercept b was 3, so plug that in as well. One other way we could find the y-intercept is to recognize that it's the y-coordinate when x is 0. Our data starts at x equals 1, but we could reduce x by 1 if we also reduce y by 2. And if we do that, we see that when x is 0, y would be 3. Hence, the y-intercept is 3. Here's a quick example to try yourself. Write a linear equation relating x and y based on this table of values. Look at how much the y's change and look at how much the x's change in order to find the slope, and then plug in that information in order to find the y-intercept. I'll put the solution on screen now. And there's our solution. This one's a little bit harder. We see that the change in y is 1 at each step, and x is changing by 2. So the slope is 1 over 2. Each time x goes up 2, y goes up 1. We can plug that known slope in, and we can plug in any of these points. Let's say we plug in 3, 7, so x equals 3. Y equals 7, and then we solve for b and get 11 over 2. Note that to go from this line to this line, we rewrote 7 as 14 over 2. That way we had common denominators, so we could solve for b. You could also use that alternative strategy to find the y-intercept. The first x value is at x equals 3, so you could subtract 3 from that to get x equals 0, but then you would have to subtract 3 times the slope of 1/2 from y in order to get the y-intercept. Either way, you would get the same answer of 11 over 2 for the y-intercept. But that's how to write a linear equation from a table of values. Let me know in the comments if you have any questions, and be sure to check out my algebra course and algebra exercises playlists in the description for more. Thanks for watching.
Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about. Stressed out, honey, I've been stressed out lately. Don't know what's what, don't know what I'm stressed about. Stressed out, sweetie, I'm stressed out. Sounds like you've been stressed out. Tell me what you're stressed about.